All right, quiet please. Quiet please. All right, a couple quick notes. David has to finish this test, so I can't hand it back to you. Plus, I haven't graded them yet. I've graded about half of it. Hey, I'm pretty disappointed. Right? I physically made you make the resource card. I literally said, write this down. I had many people couldn't tell me what a six-sided polygon was. I had many people when I said, here's a triangle with two congruent sides, could not tell me what the name of that was. I asked you guys to write that down. Where should your attention be right now, Nathan? Hey, if I take the time to, Nathan, wait outside for me right now. If I ask you to do something, right, especially as a math teacher, and I don't mean like in general, like, hey, please pick that up. I'm saying right before a test, if I say write something down, trust me when I say, I'm not going to make you write down something you're not going to use. But if I'm asking you to write it down, and it's on the piece of paper, use it. The people that miss what is the name of a six-sided, I felt bad even writing that as a question because I knew I was going to have you write down the answer on your resource card. I had people miss that. I had people miss complement and supplement, put question mark. I don't know what to do. How can I give you a practice test that literally is identical to the real test and you put a question mark? I don't know what to do. Okay, two things there. What's wrong with that? One, we sat a whole class period in class where you sat there and you did your work. Then we had a student advisement. Both times I walked around, any questions? Do you know what you're doing? Not a single person said, I don't know what I'm doing here. I don't even know what a complement or a supplement is. I had 3 people put question marks. I don't know what to do here. That's you're not doing your job. This is a blanket statement to everyone. Plenty of people got that right. But for the people who got it wrong, I'm not sure why you would put a question mark. Don't come to another test that I give unprepared. Prepare for the test. That means you do the practice test. Not once, not twice, but as many times as it takes for you to say, okay, I'm ready for the test. Most of the time it's one time. And then you make a resource card. All right, we're going to start a new chapter. It's going to start off pretty darn easy. I hand this out, please. Pretty darn easy. So get out your notebooks. Quiz next Tuesday. Here's your homework. Write it down. I don't believe there's going to be anything that I show you today that you haven't seen before in a math class. I could be wrong, but certainly I've used these words. You've heard these words before. It is what it is. This is how this chapter starts. Yes? I'm just going to say, you got to listen to the whole class, but I would be surprised if I actually show you something that you haven't been exposed to before, you've done problems on before. You just may need to be reminded of what these words mean. What these words mean. Yes?
I left my pen in my locker.
So use a pencil. Plus, it's math class. Why are you writing with a pen?
I hate writing with pencils.
Okay, so you need an erasable pen. Do you have one? Then we don't do math ever in pens if you don't have an erasable pen. How many mistakes have you seen me make since August? Well, I hope it's not a lot. If we define a lot as under 10, then yes, that's probably a true statement. The math teacher, and all math teachers make mistakes. The math teacher makes a mistake. I'm just saying you're going to make mistakes. You shouldn't do math with a pen. It gives you no opportunity to erase something. Do math with a pencil. Yes? You don't need your stuff for what we're about to do. Write it down on the piece of paper that you just got. Agreed. I'm just saying the sheet of paper that Nelia's just handed you, write this on it, and then transfer it to your notebook once you got your notebook. Okay. I will give this speech one time. You are not in lower school any longer. You are in upper school. That means you are old enough and wise enough to know that you need to come to class with a writing utensil, with a notebook, and prepared to take notes and prepared to do work. In upper school, if you don't have a pen or a pencil, you need to fix that. That means if you ask the person next to you, if they're nice enough to you, you borrow one. Walk into high school and say, I don't have a pencil, then, well, good luck. Then I hope you remember all this stuff. Showing up to your first job and saying, well, I don't know. I know you want me to put a roof on this house, but I don't have any of the tools. Well, then what? Why would I want to hire you?
Ask my dad.
Right. All right, here we go. So I'm going to claim that most of these words you've heard before. Some of you could even tell me the definition. Others are going to have to be reminded. This entire chapter deals with far more complicated things than what I'll show you today. But these are the building blocks of this chapter. So something called factors and multiples. Factors and multiples. All right. So we're going to play two games today. The first one, I'm going to give you two numbers. They're going to be whole numbers. I'm going to give you a small one and a big one. And what I'm going to ask you is, Jake. Why is this not clicking? Read. What's number one say?
No,
Number one.
oh, no.
That's it. All right. So I'm going to give you a large number. I'm going to give you a small number. Large number and a small number. And ask you, does the small number divide the big number? Okay. Sometimes these words that math teachers or other people choose are different. We might say, does 3 go into 42? Okay. So that's the first game. What we're really asking is this. Does the small number evenly divide? For those of you that don't know the definition of evenly, we mean not a decimal, right? It's a terminating number. That means it stops, doesn't go on forever, and it's not a decimal, okay? We say something evenly divides something. We say, well, it goes into it a certain number of times, and the answer is not a decimal. Clear? Does 3 go into 42?
Yes,
Well, how do you know?
because I divided
Okay. How do we divide?
big number
Okay. Big number goes what? Inside or outside?
outside.
So the big number, the second one goes inside, the small number goes outside, and we divide. 3 goes into 4 how many times? Okay. 1 times 3 is 3. Subtract. Break down your 2. Does 3 go to 12?
4.
Okay. I don't even need, it's not asking me what the answer is. It just says, does 3 go into 42? Does 3 evenly divide 42? So this is a yes or no answer. So the answer is
Yes.
yes. They're not going to give you a nice friendly number like 42. It may be like 42,162. Right? That's the process you're going to do. I don't want to do that long division 12 times right now, so I will use smaller numbers. Okay? So this is a yes or no answer. In this case, the answer is yes. Okay, so what? What is that good? Well, what we've just described, box 1, is something called a factor. If you are a whole number and you go into that larger number, you're called a factor of that number. A number that evenly divides another number. Evenly means that there's no remainder, right? There's no decimal. It terminates. You are a factor if you can evenly divide another number. The number one mistake I will see on the test is kids will look there like, okay, that makes sense to me. They don't write it down. And then on the test, I say, give me a factor, or the other word that you'll learn today, give me a multiple. And I'll have kids say, I don't know which is which. And I'll say, well, do the best you can. Because your job is to understand these definitions. Now, remember, you can have a resource card. If you show up on quiz or test day and you don't know the difference between a factor and a multiple, you're going to get these wrong. So I would suggest you need to write this down and make sure that this is on your resource card for your quiz, which is on next Tuesday. So if you are a factor, you evenly divide another number. We just figured out that 3 evenly divides 42. Any other number that evenly divides 42?
7.
7 evenly divides 42. So 7 is a factor of 42. Okay, 3 is a factor of 42. He said 7. What else?
6.
6 is a factor of 42. What else? 1 is a factor of 42.
21.
2 is a factor of 42. 21 is a factor of 42. All of them, I'm not listing them all, but here are 4 factors of 42. 3, 14, 2, 21. We mentioned 6 and 7 as well too. I believe that's all of them. Okay? I'm literally going to write a quiz that says, tell me the factors of this number. This isn't a hard thing. What the hard thing to remember is factor means this. I've been doing this quite a few years, and usually what happens is the kid shows up on quiz day or test day. I don't know what factor means, so I don't know what you're asking me. So please write it down. Tonight for homework will be fine. And then we'll move on to something else, and then come quiz day, I'll say, give me the factors of, I don't know, 36, and they'll write 72. Because they'll think a factor is a multiple or vice versa. Yeah. Yeah. All right. The other word that I used right there, box 2, is called divisible. You are divisible if there is a number that goes into you evenly. It turns out that all whole numbers are divisible. Because what number goes into any number?
1.
Not 0, but 1. 1 goes into any number. All numbers are divisible by 1. But only some numbers are divisible by 2. 7 is not divisible by 2. 7 is only divisible by and itself, right? 7 is only divisible by 1 and 7. We'll have a special name for that tomorrow. Yes. Okay, so for instance, 42 is divisible by 3. Why? Because 3 goes into 42 an even number of times. It's evenly divided by 3. It doesn't go an even number of times. Oh yeah, it does. 14 times. 42 is divisible by 14. 42 is divisible by 2. 42 is divisible by 21. That's how you use the word divisible. Generally speaking, I don't have kids miss this one. If I say, is 10 divisible by 5, they'll say yes. But factor, absolutely. I'll see kids make a mistake on that. So factor, divisible. Question on those 2 words. Okay, moving on. Some quick notes. As we already said, all numbers are divisible by 1. 1 goes into any number. Okay. Turns out that you've probably seen this before. Factors happen in pairs. On the test, I said, give me a pair of parallel lines. And I would have students say 1 line. Pair doesn't mean 1, pair means 2. So factors happen in pairs. So if we think about 42, right, how do you find, they're literally called factor pairs. Well, 2 goes into 42. Why? Because 2 times
21.
So 2 and 21 are factor pairs of 42. 2 times 21 is 42. So one way of thinking about the factors is instead of writing them like this, 2 goes into 42, 21 goes into 42, is to write the pairs that multiply together that equal the big number. Here's what I mean. 1 times 42 is,
42.
so 1 and 42 are factors of 42. 2 times 21 is,
42.
so 2 and 21 are factors. These are the factor pairs. 3 times 14, 6 times 7. You guys, maybe in previous classes, sometimes they're written horizontally, and they do rainbow things. You seen that?
Yeah.
So if I wrote all the factors of 42, it'd be 1, comma 2, comma 3, comma 6, comma 7, comma 14, comma 21, comma 42. And you probably saw factor pairs looking something like this. Remember this? Right? Kind of looks like rainbows. Yeah.
It looks like kind of like prime.
That's where we're going tomorrow, right? Private composite. All right. Okay, so 2 games today. The first one is, I just say, is it divisible by the smaller number? So I'm going to give you, they won't be friendly numbers, right? I'm going to give you 2 numbers and say, does the small one go into the big one? So guess what? No calculators. Guess what you're actually going to have to do? You're going to have to do long division, okay? So does 6 go into 138? Well, I don't know. Let's see. So what goes on the inside? Okay. Goes 138. 6 goes on the outside. We do division. 6 goes into 1, no time. 6 goes into 13.
2.
Okay. 2 times 6 is subtract 1. Carry down your 8, or I should say, drop down your 8. And 6 goes. You don't need to continue the division. As soon as you see that it evenly divides, you can stop, because this is a yes or no question. Does 6 go into 138? So you just simply put yes. You didn't have to actually finish it. I'm not asking what times 6 is 138. I'm just saying, does it go into it? Jake, how come your pencil is not moving right now? Okay. What? Get something to write with. All right. Where's your book? Go to your locker right now. Get something to write with. Make it snappy, please. All right. 8 into 154, yes or no?
No,
Well, how do you know?
I did it.
I'm still doing it.
Exactly. So we need to divide 8 into 154, so let's see the work here. 8 doesn't go into 1, but 8 does go into 15. 1 times 8 is
8,
subtract.
70.
So 7, drop down your 4.
4,
8 goes into 74,
9.
and we're out of decimal, or we're out of number spots, so it's a big NO. Okay, big NO. Yes? Could you do this tonight for homework?
Yeah.
All right, well then do these 2. Box 4. Do these 4. Box 2. I want to scratch my eye, and I know I'm not supposed to. Code it.
Oh, I just don't care. I actually do it.
Anybody stuck on what we're doing? Move the pencil, Jake. Yeah.
On here, when the 7 can go to 14,
Yeah.
and I put the 2 down to 7.
So you would be in the decimal area, so the answer is
Or no.
you got it. Is everybody stuck on the second one?
No.
No.
First one was yes or no?
No.
All right, so that was the easy one. So let me help you with the second one. So generally speaking, the second one causes problems because, just remember, long division, there's a lot of guessing and checking. So Mr. C's technique is, I'm not dividing by 18 because I can't count by 18s. I'm going to divide by
20.
I'm going to divide by 20 because I can get a quick guess and check with 20. Does 20 go into 5? Okay, does 20 go into 50?
Yeah.
How many times?
2.
Okay, see why I would do that? If not, you're counting by 18s in your head. That's hard to do. 2 times 18 is, I can do that easy. Subtract, and you get what, 14? I got a number that's smaller than 18. Life is good. Does 20 go into 14? No, so I got to bring down the 4. This looks like about 150, right? 20 goes into 150 how many times?
6.
Okay,
7.
about 7 times. So I know the answer is either going to be 6, 7, or 8. We're guessing 7. The answer is either going to be one below or one above, or it's going to be the right guess. If we guess 7, which would be the natural guess, right? If we write a 7, 7 times 8 is 56, carry your 5. 7 times 1 is 7 plus 5 is 120 or 126. So when I do this subtraction right here, I get 23. Oh, that's my guess was off by 1. But the nice thing is, you're only going to ever be off by 1 if you make your life easier. Well, we guessed too small, so therefore the right guess would be 8. Okay. Subtract, and I get a 5. Drop down my last digit possible, 4. 20 goes into 50 how many times?
3.
All right, when we guessed 2, we'd be off by 1, so we try 3 now, and it turns out that goes evenly. And you're done. So yes or no?
Yes.
That one's a big yes. Yes, question. Oh, thank you.
Oh, yeah.
What? You're not supposed to tell him. Well, he was gonna miss it, and then that's all right.
You put him in the hole. Can you be here? Can you hear me now? Yes. Mr. Shirley,
All right, thank you.
Nathan, we forgot about you.
I
know you forgot about
I never forget about a student.
Yeah, you just.
Because I have great students that remind me.
We were gonna remind you, we're gonna
All right.
let him out, but then somebody said it.
All right. So here's the next game. So we just found out if one number is a factor, we got to find all the factors. So I'm going to give you examples with really easy numbers to show you the process. Tonight for homework, they're not that easy, but I'm going to show you the process with easy numbers, ones that don't require, 5 minutes of long division. So here's the idea. The idea is that I'm going to give you a number, 42, and you're going to come up with all the factors. I'm going to show you the easiest way. The easiest way is to write factor pairs. And the easiest way is to always not guess, but to follow a pattern. Our pattern will always start with, and we'll walk up the number line. So here's how it works. We're going to make it look like factor pairs, right? So I said I'm going to give you a nice friendly one that doesn't require much thinking, 12. What are all the factors of 12? We're going to start with what number? What times 1 is 12? Okay, there's your fact. Remember, these happen in pairs. What's the number after 1? I don't care if 2 goes into it or doesn't. I'm going to consider 2. Does 2 go into 12? How many times? 2 times 6 is 12. These are your factor pairs. How about 3? Does 3 go into 12? 3 times. We know we're done. Look what happens with the numbers. As these numbers get bigger, these numbers get eventually they kind of come together. Now, sometimes they are literally the same number. Sometimes they're one off from each other. Sometimes they're more than one. But you know that you're done when there's no number between here and here, 3 and 4, that go into 12. There is no number between 3 and 4 that go into 12. Okay? Those are the factors of 12. We will write them horizontally. So when you write the answer tonight for homework, the factors of 12 are all these numbers, 1, 2, 3, 4, 6, 12. I said we'll do examples with friendly numbers so that we can get an idea of the process. Okay, box 5, factors of 16. We will always start with 1. What times 1 is 16?
16.
Well, 1 and 16 are factors of 16. Does 2 go into 16? 2 times what is 16?
8.
The 2 and 8 are factors. Notice as these numbers are getting bigger on the left, the numbers on the right are getting smaller. Does 3 go into 16? Does 4 go into 16?
Yes.
What times 4 is 16?
4.
Now, if you have a duplicate, we don't write 4 twice. Okay? So the factors of 16 are 1, 2, 4, 8, 16. See how that's done?
What about 6?
6 does not go into 16.
Oh, 18, I got those.
Yes? What happens is this. If you don't take my advice, like, oh, 16, I can do that. Let's see, 8 goes into 16, 2 goes into 16, 1 goes into 16, and 16 goes into, and you forget a number. If you do factor pairs, because you're forced to consider every number, you won't skip one. It's right there. Right? She said, why don't I put 8? Well, I did. It's right. We don't have to repeat the process. Remember, multiplication is commutative. 8 times 2 is the same as 2 times 8. All right. This is a friendly number, but it is large. Generally speaking, this is the one, if I put on a quiz, you would miss. Maybe not all the factors, but you'd skip one. If you do them in order, you will not skip them. What's the first number?
100.
1 in 100, because 1 times 100 is 100. Does 2 go into 100?
Yeah.
How many times?
50.
2 times 50 is 100. Then we consider 3. Does 3 go into 100?
No.
3 goes into 90. That would leave 10 left over. 3 doesn't go into 10. 3 doesn't work. How about 4?
25.
4 times 25 is 100. No, I'm just going straight down. I'm not trying to jump. Oh, I already know what 10 goes into 100. I'm not skipping the 10. I'm going straight down the numbers. As these numbers get bigger, these get smaller. Eventually, they kind of meet. Does 5 go into 100?
Yeah.
Yeah.
5 times
20.
20. We're getting closer to each other. Does 6 go into 100?
No.
6 goes into 90, but 6 does not go into 10. Does 7 go into?
No.
7 goes into 70, but it doesn't go into 30. Why am I picking those numbers?
Because they're next.
Because 70 plus 30 is 100. 7 goes into 70, but it doesn't go into 30, therefore it can't go into 100. Does 8?
No.
Because 8 goes into,
80.
but it doesn't go into
20.
20. Right? Because 80 plus 20 is 100. You see how I'm doing that? If you can't do it that way, that's fine. Then you got to do long division. You might. I'm picking two numbers that when you add up, they equal 100, 80 and 20. Because I know 8 times 10 is 80. But boy, 8 doesn't go into 20. Therefore, I know that 8 can't go into 100. Okay? If you can't do that math in your head, you don't have to, then you got to do long division. See if 8 goes into 100. 9? Why not?
9 goes into 90.
But not into 10. 10?
Yeah.
10 times 10. And notice the numbers just met. They won't always meet. They won't always be one away from each other, but they will be really close that there's no other number between them that goes into that number. So those are your factor pairs. 1, 2, 4, 5, 10, 20, 25, 50, 100. If I ask you to do this and you don't follow that pattern, it's not that kids will forget what to do, but just skip one by accident. Follow this pattern. Follow that pattern, right? That's a lot of numbers. All right, next box, you got one to try all by yourself, and that number is 90. Do it by yourself. Do not skip. Start with 1 and work your way through everything. Everybody know what you're doing? Nathan? Okay, good. Lori, already done? Nice. Jake, you know what you're doing? Excellent. Yes? Sure. Yes. What's the number do we start with?
I started with 1.
1 times what is 90? So 1 and 90. What's the next number?
2
Just
times
2.
45.
What's the next number?
3.
Times. Then you need to do long division. So then you pull out long division. Let's see if 3 goes into 90. Does 3 go into 9? How many times? 3 times 3 is? Subtract, we get 0. Yeah, it goes into 90. 3 times.
Oh, I get your thing now.
Mask, 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 mask. Boy, I got to resist the urge to make a joke about that.
What?
What?
Don't worry.
Nothing.
So I'm gonna get the wrong round.
Do it.
No, I'm not
Do
going
it.
to.
Do it. I don't take anything away.
Put your mask on and do your math.
No, it's on.
Just say
I
it.
don't do it. Oh, Lord, breathe out my eyes.
Or
No, tell the joke.
I'm not telling the joke. You're doing your math.
I already
All right.
finished.
Then you're going to sit there quietly and wait for all the rest of the people.
That's all the joke. Do it. I don't take anything.
Lord, stop. Stop. All right, let's see if we can get this. So if I do the factor pairs, we've already done 1 and 90. We've already done 2 and 45, and Mason and I did 3 and 30. Does 4 go into 90? Why not? 4 goes into 80, but it doesn't go into 10, right? How about 5?
Yes.
Okay, so 5 goes, and for those of you who know the rule of 5, any number that ends in 0 or 5, 5 goes into. What is it? 18, okay. Notice the numbers are getting closer. Does 6 go into 90?
No.
6 goes into 60. Does 6 go into 30?
Yeah.
So 6 goes into 90, right? So 6 times, is it 15? Is that right?
Yeah.
6 times 15? Okay. 6 times 5 is 30. Carry a 3.
Yeah.
Does 7 go into 90?
No.
7 goes into,
70.
but doesn't go into,
20.
okay, 8. 8 goes into 80, but doesn't go into,
10.
okay, 9.
Yeah.
9 times.
10.
Notice Oh, I left it. My animation's out of order here. Notice that 9 and 10 are 1 off. It won't always be 1 off. It could be 12 off, right? But the difference is the numbers will come together and there'll be no number between your last two that goes into the 9. Okay? That's a lot of numbers. Yes?
Tell a joke.
No, not Laura, please stop. All right. Next game. Write this down, please. I said there will be 2 words that I'll have kids. I'll give the quiz, and they'll say, I don't know the difference between these 2 words. You must know the difference between these 2 words. The first one was factor. That is a number that goes evenly into another number. And the other one is a multiple. A multiple is the product is a fancy word for multiplication. Product of a given number. I will give you the number. And any whole number. Yes.
That says 9, but on here it says 8 where I was supposed to write it.
Wherever the next empty spot was. Multiple, the product of a given number. I will give you the number. You will be creating multiples. You've been doing this since 2nd or 3rd grade. The difference is 2nd or 3rd grade, your teacher didn't use the word multiple. That's where it comes from. Your teacher said, all right, 3rd graders, let's now count by 3s. When you count by 3s, you are stating the multiples of 3. In other words, the first 3 you said was 3 times 1, which is
3.
and then you did
6.
because that's what
What comes next?
why?
Because you're counting by 3s.
Because that's what 3 times 2 is. It's not because 6 is the next number by chance. It's because that's what 3 times 2 is. What's the next number?
12.
9. Why?
Because you said so.
No, because that's what 3 times 3 is. What's the next one?
12.
Why 12, not 13?
3 times 4.
Because that's what 3 times 4. We're following a pattern here. When you count by things, in other words, when you state the multiples of this given number, right, you're really doing multiplication. Like, no, I'm not doing that. Remember, multiplication is repeated addition. So, yes, you were multiplying. And yes, you're adding. Okay? Tonight for homework, they're going to ask you to write 5 multiples. I have no student that ever has told me, I don't get this. What's a multiple? Yet come Tuesday on the quiz day, if you don't have it written in your notes, what a multiple is, an example, and what a factor is, I'll have kids like, I don't know, is this the one that we're counting by 3s, or is this the one where 3 goes into it? There's nothing really descriptive about the word multiple, other than the word multiply. Okay? Laura?
You created multiplication.
It is a natural thing. I'll just say, no one creates math. Math exists. We may not have discovered all math, but it's like nothing makes math. Right? Don't know the answer to who named it multiplication. But I'm saying no one invented multiplication. Multiplication just exists. Okay?
Listen, someone has
All right.
1 minute. You get one.
So 3 is just all the
What did you see?
1 plus 1.
No one makes that up. It just exists. The concept of this and this equals the value 2 is not something someone invented. It just exists. If we were, God forbid, if humans did not exist, the fact that this and this equals 2 would still be true. Humans did not invent math, right? Humans didn't discover math, right? What we invented or discovered was a way to graphically represent the concepts. The fact that that shape and symbol right there means 6, yeah, humans invented that. But the idea of 6 doesn't require humans, right? All right, let's make some multiples. So box number 9, the real box number 9, it says give me 5 multiples of 12. It doesn't say give me the first 5. It says give me 5. Obviously, the easiest ones are the first 5, but you don't have to give me them in order. You don't have to give it to me from least to greatest. You don't have to give me the first 5. You can give me, I don't know, you can multiply by 1,000 if you'd like to. Please don't, right? Yes?
Maddie asked if it was made by
Well, monkeys can do math, right? Right? Dogs can do math, cats can do math. It's just the kind of math they can do is what we would say would be limited.
What's limited?
I've said this story before. If I take a piece of string cheese and I cut it up in little tiny things and I put up two piles on my floor, one is large and one is small. My dog, and I hold the dog and let it go. The dog immediately goes to the larger one. You tell me that's not math? That's greater than less than. The dog is doing math. Now, what kind of math? Well, it's kind of limited. Oh, by the way, the dog's going to eat the smaller pile next, right? But the dog is making a choice, and that choice is based upon mathematical concept of quantity. The dog goes to the one with the largest quantity first. That's math. By the way, all animals will do that, right? They have eyeballs that can see. Fish will go to the largest quantity first. You put one little piece over here and 40 big pieces, the fish will swim to where the larger things are at, right? That is math, not very complicated math, okay? All right, back up here, multiples of 12, let's go, get it done. Oh, what did you write?
12, 24, 36, 48.
Those are the ones that I chose as well too, because those are the easiest ones.
Oh, I just took random things that I knew.
Okay. Tonight for homework, they're going to ask you to write multiples of a given number. Maddie, mask on, please. 19 are not friendly. Okay.
How many multiples would you say?
5.
All right. Do we need to do multiples of 30 or we got this concept?
30.
Oh, by the way, the multiples of 3 and the multiples of 30 are,
The same. Just
well,
a 0.
they're just different by a 0.
I don't understand.
Count by 30s.
60.
You're giving me the multiples. What are you doing mathematically? You're taking the given number and you're multiplying. 30 times 1 is 30. 30 times 2 is 60. That's why you said 30, 60, 90. 30 times 3 is 90. That's what you're doing. Okay? Can you do that by yourself now? Okay. All right, last idea. This is a obvious one to some of you, but to others of you, you don't even know about this. What's an even number?
An even number.
You're not allowed to give me an example because that's not a definition. Jake, what's an even number?
An even number is a number that's easier to like.
See what I mean? Seems like an easy thing. Can't do it. Nathan, what's an even number? Yes.
So an even number is a number that you can divide.
No. I can divide 49 by 7 evenly, and neither one of those numbers are even.
You'll get 7.
Laura?
Where 2 numbers, you can add and multiply and things.
I just had 6 people. What is an even number?
May I say,
First, give me the definition.
I know it.
So let's write this down.
And we're just gonna look it up on Google and then tell us the answer.
I've already heard the definition. Somebody already yelled it out.
No, it's a number that's not on.
Oh my God, he's so smart.
Okay, so that literally has a literary term. We would say that begs the question. You know what that means?
Now, what's an odd number that you're begging the question?
Let me think of a better one because the classic one they use for beg the question is kind of offensive.
I don't care. What's an odd number?
Well, this is not given to you by no stretch of the imagination. But whenever you look up the definition of begs a question, this is the example they give. They say, "Well, that's ugly," and you say, "Well, why is that ugly?" And you say, "Because it's not beautiful." We say that begs the question because, well, I don't know what either one of those means now. Just because you said one is opposite. So you can't say that an odd number is just the opposite of even or vice versa, unless you define one. So we still need to define what an even number is.
I know what an even number is.
An even number.
An even number is a number divisible by 2.
Write that down, please. Since only one per, I heard somebody else yell it out earlier.
I was gonna say it.
This is a number that is divisible by 2. And remember, we've defined what divisible with in box 2. That means 2 goes into it evenly. Well, luckily for us, we've now defined one. So now I can use Caitlin's definition for odd number. So Caitlin, what's the definition of an odd number? Now you are allowed, because we define even number, now you are allowed to say,
A number that's not.
now we can say that. Why? Because we define what an even number is. Now, well, yeah, exactly. Because I'm going to ask you, what's an odd number? Well, it's a number that's not even. But if you tell me that an even number is not odd, an odd number is not even, you've told me nothing. But since we said that an even number is divisible by 2, well, if you're not even, that means you're not divisible by 2. Now, you ready for your mind to be blown?
No.
Yes, I guess.
No.
How do you go from one even number to the next one?
You
Okay.
multiply.
How do you go from one even number to the next one?
Add
You add 2. How do you go from one odd number to the next one?
Add 3.
Add
Add 3.
Add 2.
Add 2.
How do you go from one odd number to the next one?
Add plus
Add 1.
That's crazy.
3.
We define an even number as divisible by 2. Odd numbers are not divisible by 2. Yet, to get from one odd number to the next one, the next consecutive one, we do the same thing as we do for even numbers. We add 2.
But you have to start at 1 for it to be an odd number.
But that was my point. I said, how do you go from one odd number to the next consecutive one?
Because you have to start at
If you start at an odd number and you add 2, you wind up at an odd number. If you started an even number and you add 2, you wind up. If I started an even number and I add an odd number, guess what happens?
you get an odd number.
No. Or I would say yes. Yes, you said it. Okay. If you start at an even number and you add an odd number, you get 2. If you start it, be careful. You start at an odd number and you add an odd number,
You get an even number.
right? That's crazy.
That's big for an
Odd plus odd.
Okay. What is an even number times an even number?
Even.
It'll be an even number.
What is an odd number times an odd
It'll
number?
be an odd number.
Even.
It's even.
All right.
That's crazy.
That's weird.
Now, what about 3 times 3? That's 9.
What's
Is
What did
that
I say?
an odd number plus an odd
no,
number?
no, no. Did I say plus or did I say multiply?
You said plus.
I'm gonna have to review. I may have said that incorrectly. Let's back up and make sure. What's an odd number plus an odd number?
Even number.
Crazy. What's an even number plus an even number?
Even number.
How do we get odd numbers?
Even plus odd.
By multiplying.
2
Add
ways.
an odd and add an even.
2 ways. If we start with an even number to get to an odd number, we must add. We start with an odd number to get to an odd number, we must add
2.
an even number. That's crazy. I think I said it wrong for multiplication. So even number times an even number is an odd number times an odd number. And I'll say it correctly. 7 times 7 is
49.
so an odd number. Now I've said it correctly. All right. How do we get to an even number if we start with an odd number if we use multiplication? What? You raise your hand. What? If we start with an odd number and we want to use multiplication, how do we get to an even number?
Times 2.
We
Everything's times 2 is even.
I said through multiplication.
said the multiplication. You multiply.
If I start with an odd number and I use multiplication, how do I get to an even number?
You multiply by 2.
So in other words, by
Even.
an even number. All right, now I said it correctly. I apologize.
Wait, you multiply by an even number?
To get to an even number, if you start with an odd number, you must multiply, well, by an even number.
Say that.
All right, yes. I'm not sure why everyone's packing up. We're not done.
You add 23.
So if you take an odd number, you add an odd number, you will always get.
No, if you had any even odd numbers,
Now she wants to do 3, so let's think this through.
you get an odd number.
Because we are going to add 2 numbers at a time, we got to consider what happens when we add the first 2. So if they're all add, an odd plus an odd is a,
Even.
and an even plus an odd is always.
Odd.
Is that right?
Yeah.
That's right. So 3 odds, if you're adding, will always give you
Odd.
an odd.
I want to
How about 4 odds?
even.
Well, 2 odds always adds up to,
Even.
2 odds always adds up to,
Even.
and even always adds up to even. You can think of it that way. That actually isn't right because, well, if it's as long as it's addition of positive numbers, then addition is commutative. We can move around any way we want to. And we can do the associative property as well, too. As soon as we throw some minuses in there, things get a little bit dicier. Okay? All right, questions on the 2 things. 1, making or determining whether things are factors, and then 2, determining what are multiples. What was the warning that I gave you at the start of class?
You were gonna mix stuff and you wouldn't know which one's which.
You take the quiz and you walk into the quiz without it written on a piece of paper, and it isn't locked in your brain, you will get both of these wrong. I will not provide you any examples. I will just say, you know, give me the factors, give me the multiples of a given number. I will say, I don't know, 17, and I will say, what are the factors? What are the multiples? If you don't have this written down, you will get it backwards. I see it all the time, right? And it saddens my mathematical heart when I say it like 6 or 7 times, which I have today, and I don't have kids write it down for a quiz. So make sure you walk in on Tuesday to the quiz with an understanding. For me, if I'm going to write it down, not only am I going to write the word and the definition, I'm going to put an example. Hey, here are the factors of 42. Here are the multiples of 42, just so that I can see that in front of my face. So that when I go, oh, it says the word multiple. That's where I take 42 and I multiply it. Oh, it says factors. That's the one where I divide. Okay? Make sure you understand the difference. Antonio, yes? Richard, yes? Okay. Danny? All right. Good? All right, back it up.
Oh, wait, we do. He actually let us pack up early.
All right.
I know, right? Coach said that he's gonna make.
This was 5-1, so the first section of any chapter is usually pretty slow. Eleanor, any questions?
Nope, none.
Cool. See you tomorrow.
Okay, bye.
Bye.